The fact that the environment outside is lethal. You have to wear a spacesuit to go outside. You have to do everything in a spacesuit. Imagine that you had to do this yourself. Imagine that you had to live on Mars for 18 months. How would you go about planning that? A trip to Mars is, in some sense, the mother of all camping trips.
Get ready, world. The universe is about to change.
The camping trip is successful only if you plan it right. You will not be able to improvise an 18-month stay at the surface of Mars. And so what we're going to learn here is how to optimize our fieldwork while pretending, if you will, that the environment is lethal.
I'm sorry, Frank, say it one more time.
I've got the screwdriver I need in my pocket.
So let me go for it there.
I can't see.
No, I get it. This is obviously the way to do it.
So these are the rules that we are going to follow. First of all, we cannot go outside without a spacesuit to do any of our planned activities or tasks. On Mars, the only habitable environment that you can live in is inside the habitat. Outside, you're faced with death. Once we're outdoors, we're going to assume that we have 3 hours of oxygen in our backpack, which includes 30 minutes of you shouldn't touch it safety margin, and another 3 hours of oxygen on our ATVs.
Okay, so I think we've used about 2/3 of our oxygen on this trip.
So what would happen if you stay out longer than the amount of oxygen you have? In principle, you die and therefore disappear out of the simulation. On Mars, one of the most important resources will be water. And while we think that there is water available on Mars in some form, we probably will not be counting on it on the early missions. The total amount of water that we have per day will be 30 gallons. And for 7 people, that's very little. We need to have some experience with keeping track of all these things. And in so doing, we will learn how to do Mars effectively and efficiently.
I say everything does take a little longer here.
Much like real astronauts would do if they had just landed on the frigid Martian surface, the first simulation crew has to complete the installation of systems before even thinking about going out to explore. The task here is to connect up a series of long hoses to bring those 30 gallons of fresh water from a nearby stream each day, and also remove wastewater. The hope is to learn important lessons with every activity.
10 minutes to do this, I love it.
Now, what we're interested in here is in constructive criticism. Bear in mind one thing, though, is that the suit is not meant to be comfortable or easy to work in. It's, on the contrary, supposed to be there to bother you and be in your face. So, with that in mind, why don't you go ahead, Frank?
Well, the fogging was probably the biggest problem. It was like it was raining in there. There was water on it, so...
Okay, so fogging, that's an issue, all right. That sounds good.
One thing we noticed that working together, you can't see your pockets. So it was easier for me to get stuff out of Sam's pocket and him to get stuff out of my pockets.
Okay, we got it. Go ahead.
It just has to stay on there,
That's
yeah?
about as tight as you get it, huh?
One thing we talked about is maybe putting a little mirror
Right, that's
on
what regular suits have in
Yeah.
the space shuttle program.
Okay, Frank, you can give me a high five for that one. That's awesome. Absolutely.
After a successful day's work, it's time for relaxation and a space food-like meal. On future extravehicular activities, or EVAs, the crew will begin exploring the incredible Mars-like world that awaits them outside the habitat.
Devon Island is the largest uninhabited island on our planet. We've been coming up here for the past 5 years now as part of the NASA Houghton Mars project. It's an international collaboration between, above all, NASA Ames Research Center and the SETI Institute. You have geologists here, biologists, computer scientists, roboticists, people who design spacesuits and life support systems. We come here to learn how to explore Mars, to learn how to compare the Earth and Mars, to learn from the differences and the similarities between our two worlds. This, in some sense, is a miniature Mars. It's Mars Park.
Among the most striking similarities between Devon Island and Mars are the water and ice-carved gullies that line the cliffs here. By studying these, scientists hope to understand the formation of Martian gullies, which look eerily similar. But that's just the beginning of the uncanny parallels between Mars and Devon Island.
The place is cold, barren, mostly unvegetated, windy, dusty, and when you're here you get this profound sense that you could be wandering across one of the plains of Mars, one of the rocky plains that were visited by the Viking landers, for example. We see impact craters, ancient hot springs here, ancient lake beds like the one that you see behind me, and also canyons and valleys around the crater. All of these features in this high Arctic desert look like features that we see on Mars. In addition to studying the geology and the biology of this place, we are also running a program in exploration research. We're trying to understand how to explore other planets, and Mars in particular, better with robots and one day humans.
One key activity here on Devon Island, besides the Mars Society habitat, is helping in the development of a Mars spacesuit.
Houston, you're a go for landing, over. Roger, understand, go for landing. You're looking great.
Until now, the farthest humans have ever ventured away from Earth has been the Moon. The spacesuits we used during the Apollo missions were like big, overinflated balloons, not great for mobility. And after 3 days, the longest time astronauts ever spent on the Moon, lunar dust was clogging up the spacesuit joints. By contrast, a Mars suit will have to be highly mobile and last for 18 months of active fieldwork, or else the mission could be a failure. Over the years, NASA has conducted some basic research on a Mars suit. But without the budget to send humans to Mars, NASA has to focus on other things.
All right, what we're going to do.
In part, that's why spacesuit maker Hamilton Sundstrand is investing its own money to work on Devon Island.
This spacesuit represents our best attempt at an engineering model used to look at the interactions between the astronaut and the spacesuit. So we're up here trying to learn what types of things the scientists and geologists might need when they're going out on their EVAs and doing real geology work.
Mars suits will have to be strong and airtight, carry loads of communication gear and oxygen, provide heating and cooling systems, and protect from ultraviolet radiation. Fortunately, things weigh a lot less on Mars.
The gravity on Mars is approximately 1/3 of what it is on the Earth, so something around the range of 145 some odd pounds is what we're looking for to target the weight of a spacesuit, and that would be equivalent to about 50 pounds on Mars.
The hope is to develop a suit that not only keeps astronauts alive, but lets them be productive explorers.
Like in the later lunar adventures on Mars, the suits will be used by geologists. So we have up here is a lot of geologists exploring the crater, and they'll be walking around the suit, and we're trying to find out if the bubble position's correct, if the shoulder positions are correct, see if it hits that display or not, if the different interfaces that we're adding to the suit are going to work out for someone that's a scientist, and be transparent to them at the same time.
Don't break the bubble, the only one we got. It's very tough to create a suit for Mars because of the environment. We're looking at sharp, jagged rocks, we're looking at a lot of tough things that abrade, and currently we don't have materials that we think that could last that long for an entire mission without having problems.
The bubble's going to withstand a hammerhead. The new computer.
If we look at what kind of technology we're going to need to build a spacesuit, we're still a bunch of years off.
The inside, I'll get to the outside.
Dr. Lee, you ready?
Yes, sir.
When they aren't participating in the habitat simulation, scientists here are happy to serve as guinea pigs for all sorts of new spacesuit technology.
See you the second time.